Hi everyone, you finally made it. This is Unit 14 exam review for Geometry A. This should be the last exam review packet that you're working on, and this unit covered probability. So let's take a look at the first one. One red token and one black token are placed in a bag. A token is drawn, the color is recorded, it is then returned to the bag. Remember that with all these probability problems, that's an important fact. Okay, is it with replacement or without replacement? This question is asking us to make an organized list, a table, and a tree diagram. And this is probably the first time you've seen one of these that says and. So we do have to do all three. So an organized list would be just a list of the possible outcomes. And our options are red and black, and we're doing two different draws. So I could get a red and a red. Okay? Or I could get a red and a black. Or I could get a black and a black, or I could get a black and a red. Those are our four options. Okay, so that's the list. If I were to make a table, I would do something along these lines. Okay, I'm going to set up a table. Okay. And up here at the top, we'll say this is draw 1, and then this is draw 2. And then draw 1 could be red or black. Draw 2 could be red or black. And then I'm going to fill this in. This is going to be really similar to like a Punnett square in biology. So this would be red, red. This would be red, black. This would be black, red. And this would be black, black. And you'll notice that these are the same four options here that we came up with in our list when we just kind of tried to think through our options. And then it also wants us to do a tree diagram. And tree diagrams for these seem to be kind of tricky if you've only got so few options. When I throw problems at you guys that have lots of options, you get right to work on the tree. But somehow when I give you things with only two options, it becomes harder. So the first draw, we could have red or black. And then after each one of those, we could have red or black. And again, this leads you to the same conclusion as the other two methods. See here we've got red, red, or red, black, or black, red, or black, black. So hopefully you found one of these options to be really helpful for you throughout the course of this unit. Okay, let's look at number 2. A chef's salad at a local restaurant comes with a choice of French, ranch, or blue cheese dressing and optional toppings of cheese, turkey, and eggs. Here's what's tricky about this one. Well, we'll get started. We'll do the first layer and then we'll talk about what's tricky. So we have a choice of French, ranch, or blue cheese. I'm going to try to make this as large as I can. French, ranch, blue cheese. So here are my three dressing options. Okay. Now what you have to be careful of here is that we don't want to just say cheese, turkey, eggs, because we have the option of having cheese or no cheese. We have the option of having turkey or no turkey. We could have cheese and turkey if we wanted to. So what we're going to have to do is off of each one of these, say cheese, no cheese, and then off of each of those we would go to turkey. So we would have to say turkey, no turkey, turkey, no turkey, turkey, no turkey. I'm going to go ahead and fill the rest of this in and then just let you take a look at it. Okay, here's my final diagram. I know this looks a little messy. It's kind of hard to write as small as I would like to on this thing, but off of each of my turkey, no turkey options, I went egg, no egg. I went egg, no egg. From here I went egg, no egg. Because you could have the possibility of having French dressing with no cheese, turkey, and eggs. You could have the option of having ranch with no cheese, no turkey, and eggs. Okay, so you have to make sure you account for all of those different possibilities. If I was going to ask you a question like how many different possibilities are there, if you were doing the multiplication by the fundamental counting principle, I have 3 choices of dressing, and then I have 2 choices for cheese, I have 2 choices for turkey, and 2 choices for eggs, which should give me, let's see, that's 24 different salads. Okay, if you did it with only having the option of cheese, turkey, and eggs after your dressing choices, you would only have 9 choices. But there really are 24 different salads you can make here. And that's what I would get if I counted up all of these end branches. Okay, let's move on to the back. Okay, so new cars are available with all of these options. How many different cars could we create in the chosen make and model? So here are all our different options here, okay? And remember, by the fundamental counting principle, to figure out the number of combinations, I'm just going to multiply these together. So let me write down what I'm doing here so you can follow me. It would be 11 times 7, times 5, times 3, times 6, times 4, times 3, and I'm just going to type that into a calculator real quick. And that would come out to be, sorry, my handwriting's always so messy when I write with this thing, 83,160 different cars. Okay, so cars with a variety of options. Okay, let's look at number 4. Eli and Mia along with 30 other people, and I'm going to stop you right there so you can read that. So Eli and Mia along with 30 other people, that means we're dealing with 32 people total. Hopefully you caught that. Okay? Contestants are called at random to perform for the judges. What is the probability Eli will be called to perform first and Mia will be called second? Well, because it gives you an order that it wants them called in, it doesn't say what is the probability that Eli and Mia will be called as the first 2. It says it wants Eli to be first and Mia to be second. That's a permutation because order matters. Okay? And so that means we're going to be doing 32 P2, and that can go straight into your calculator. On a graphing calculator, remember this is under the math menu, and then you go to the right to get to probability. So there are 992 different ways that I can call 2 people up out of the 32. I'm given a very specific way. I want this one possibility out of those 992. And so since this question is asking for a probability, my probability would be 1 out of 992. Okay? Okay. Number 5, a box of floor tiles contains 5 blue, 2 gold, and 2 green tiles in random order. The desired pattern is blue, gold, blue, green, blue, gold, blue, green. If you selected a permutation, and this one comes right out and tells you that it wants you using permutations of these tiles at random, what is the probability, excuse me, that they'll be in the correct sequence? So it looks like we're working with 9 tiles total, and I got that from just adding these up. Okay, so we've got 9 total here. And so I could arrange these in 9 factorial different ways. But I want to take out the possibility of swapping 2 of the same tiles. Like if I were to rearrange the blue tiles, I don't want that to count as a different arrangement. So I need to divide by my repeaters. I have 5 blue ones. I have 2 gold and 2 green. Okay, so I'm going to do 9 factorial divided by 5 factorial, 2 factorial, 2 factorial. And if you're going to do that in your calculator all at once, you have to make sure you put this bottom part in parentheses. Okay, let me type that in real quick. So here, this tells me that there are 756 different ways I could arrange the tiles. And that's 756 unique ways, meaning we're not counting if one blue tile is on the left and one's on the right, or if those same 2 are reversed. So the probability that we would get the correct sequence, because the correct sequence is just one possibility, our final probability here would be 1 out of 756. Okay? Okay, let's move on. A set of alphabet magnets are placed in a bag. 5 magnets are drawn from the bag at random. What is the probability that they will be A, E, I, O, and U? Well, it doesn't say that I have to pull them in that order, okay, and that's going to be important. If they don't have to be in that order, I'm just going to make a note here, no order. This is going to be a combination problem, okay? And I'm assuming if a set of alphabet magnets, that would be 26 magnets because there are 26 letters in the alphabet. So we would do 26C5 because I want to know how many different groups of 5 letters could I pull out. And it looks like that would come out to be 65,780. And again, I want a very specific group of those letters. So my probability would be 1 out of 65,780. Okay? Okay, number 7. Point Z is chosen at random on AD. Find the probability that Z is on AB. Well, AD as a whole, if I measured this entire distance, would be 2 plus 2 plus 7. So my entire distance here is 9 units. Okay? And let's see, AB is 2 of those units. So my probability would be 2 out of 9. And I guess now would be a good time to mention that I've been leaving my answers as fractions, but I could make those into decimals or percentages, depending on what your teacher wants. And especially when it comes to the exam, if it's multiple choice, you may have your answer as a fraction and your choices might be percentages. So you need to know how to convert. If this is 2 out of 9, I would just type 2 divided by 9 into my calculator. I get 0.2 repeating. And then I would move that decimal 2 to the right to make it a percentage. So this would equal 22.2%. So depending on how your teacher wants your answers and how your exam questions are laid out, any one of these answers would be correct. Okay. The rest of this packet we'll pick up in a second video, so stay tuned for that.